Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.79. While solving this problem, we will be using Ohm's law. According to Ohm's law, voltage across any resistance R is always equal to the product of current through that resistance and the value of resistance itself. We also will be using parallel equivalent resistance calculation formula. R equivalent of two parallel connected resistances is calculated by taking the product of both resistances dividing by their sum. Now move towards the problem. Exercise problem number 2.79. Find voltage VAB and current I1 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find voltage between these 2 points labeled as VAB and current through this branch labeled as I1. So without wasting time, let's proceed towards the solution. First of all, we will simplify this network in order to calculate total supplied current. Later on, we will use that total supplied current to calculate current I1 as well as voltage across this 3 kilo ohm resistance. And whenever we will have the value of voltage across 3 kilo ohm resistance, we will be able to calculate voltage between these 2 points that are the sum of these two voltages. So first of all, we will simplify this network. These two resistances are connected in parallel connection and both have same values. So we can find their equivalent resistance by dividing the resistance of a single resistance with the number of resistances. In this case, the value of a single resistance is 6 kilo ohm and the number of parallel connected resistances is 2. So their equivalent resistance will be 3 kilo ohm. Modify the circuit by replacing these two resistances with a single resistance having the value of 3 kilo ohm. Now this 3 kilo ohm and 7 kilo ohm are converted into series connection. Their equivalent resistance will be equal to the sum of both resistances. Sum of these resistances will be equal to 10 kilo ohm. Modify the circuit by replacing these two resistances with a single resistance having the value of 10 kilo ohm. These 8 kilo ohm resistances are also connected in parallel connection and both have same values. So their equivalent resistance will be calculated by dividing the value of a single resistance with the number of parallel connected resistances. In this case, 8 kilo ohm divided by 2. R equivalent of these two parallel connected resistances will be 4 kilo ohm. Modify the circuit by replacing these two resistances with a single resistance having the value of 4 kilo ohm. Now these two resistances are connected in series connection, so we will find their equivalent resistance by adding the values of both resistances. Their sum will be equal to 10 kilo ohm. Replace these resistances with a single resistance having the value of 10 kilo ohm. Now for further simplification, these two 10 kilo ohm resistances are connected in parallel connection and both have same values. So we will find their equivalent resistance by dividing 10 kilo ohm with 2 because the number of resistances are 2 connected in parallel connection. R equivalent will be equal to 10k divided by 2. It will result 5 kilo ohm. So we will modify the circuit by replacing these two resistances with a single resistance having the value of 5 kilo ohm. Now the circuit is simplified and it is converted into a simple series network. We can find total supplied current by dividing total supplied voltage with total resistance of this network. In this case, because the resistances are connected in series connection, so their sum will be equal to total resistance of this network. 5 kilo ohm plus 3 kilo ohm plus 2 kilo ohm, it will become 10 kilo ohm. Total supplied voltage is 40 volt. So total supplied current will be equal to 40 divided by 10 kilo ohm. The answer will be 4 milliampere. In this network, total supplied current is 4 milliampere, which is being supplied through this voltage source. The direction of current will be counterclockwise, leaving from positive terminal and entering from negative terminal of this voltage source. Due to series connection of these two resistances with voltage source, Same 4 milliampere current will flow from these two resistances. We have calculated total supplied current. Now we will expand the network back towards original form to calculate current I1 and voltage VAB. For that purpose, if we observe, this 5 kilo ohm was the combination of two 10 kilo ohm resistances connected in parallel connection. So we will replace this 5 kilo ohm with two 10 kilo ohm resistances connected in parallel connection. Modify the circuit. In this network, the total supplied current that is coming on this node is 4 milliampere and it is distributing among these two branches. Both branches have same resistance values, so this current will be equally divided in both branches. So we can say that 2 milliampere current will flow from this branch and 2 milliampere current will flow from this branch. And the direction of current through these branches will be clockwise direction in this branch and counterclockwise direction in this branch. Modify the circuit. Now if we remember, this 10 kilo ohm resistance was the combination of 3 kilo ohm and 7 kilo ohm connected in series connection. Similarly, this 10 kilo ohm was the equivalent resistance of 6 kilo ohm and 4 kilo ohm connected in series connection. So we can replace these two resistances with their corresponding resistances in original form. Modify the circuit. In this network, value of current I1 will be 2 milliampere because of same branch. But the direction of current I1 given in the network is opposite to the direction of original current. So the value of current I1 will be minus 2 milliampere. Here minus sign is indicating that the direction of current I1 inside this network is taken in wrong direction. The actual direction of current is opposite to the assumed direction of current I1. Now we do not have to further expand the network because we have calculated current I1. Voltage across this 3 kilo ohm resistance can be calculated using total supplied current. So we will use Ohm's law to calculate voltage across this 3 kilo ohm resistance. Voltage across this resistance will be the product of current through it and the value of resistance. Current through this resistance is 4 milliampere and the value of resistance is 3 kilo ohm. Product of 4 milliampere and 3 kilo ohm will be 12 volt only. Milli will cancel out with K. Modify this network by placing the value of calculated voltage along with its polarity. Here the polarity of this calculated voltage is taken according to the direction of current through this branch. In this branch, the direction of current was upward. Current entering terminal is taken with positive sign and current leaving terminal is taken with negative sign in the light of passive sign convention theory. Similarly, polarity notation across these 2 points A and B are taken with this reference. VAB is indicating that point A would be on higher potential than point B. So point A will be positive and point B will be negative. Now we will apply Kirchoff's voltage law inside this semi-closed loop to calculate voltage VAB. For that purpose, we will assume the direction of current inside this semi-closed loop in clockwise direction. Start from this 12 volt source. Current entering terminal is positive because of clockwise direction of current. So 12 volt will be taken with positive sign. Move to next voltage source element. Current entering terminal will be negative. So 40 volt is taken with negative sign. Similarly, current entering terminal will be positive for VAB. So VAB is taken with positive sign. Now subtract 12 from 40. The answer will be minus 28 volt. And place minus 28 volt on the other hand side of equal to calculate the value of VAB. That will become 28 volt. So the value of current I1 inside this network is minus 2 milliampere and value of voltage VAB inside this network is 28 volt. This was exercise problem number 2.79. Thank you. See you again in next video.